Okay, this problem asks us to find the slope and the equation of the tangent line to the graph of the function at the given value of x. So if this was a linear function, finding the slope would be easy, right? It's just the coefficient in front of the x term, but this is not a linear function, and its slope changes throughout the graph. So that means we need to use the derivative to give us a formula to find the slope of this function, or the slope of the tangent line to this function at any given value of x. So that's where the derivative comes in handy. So the slope of the tangent line So the slope of tangent to f at x is f prime at x. So that's going to be our m, right? So that's going to be our slope. So we first need to find that. So f prime at x is equal to, the derivative of x to the fourth is 4x cubed minus the derivative of 20x squared, so that's going to be 20 times 2x or 40x, plus the derivative of 64, which is a constant, which is 0. So that's the slope of the tangent line at any x value, but we want it specifically at x equals 1. So f prime at 1 is equal to 4 times 1 cubed minus 40 times 1, which is 4 minus 40, which is negative 36. So the slope of the tangent line to this function at 1 is negative 36. Now to find the equation of the tangent line, you not only need the slope, but you eventually need the y-intercept. But we're going to go ahead and use the y minus y coordinate of a point on the line is equal to slope times x minus an x coordinate on the line. We're going to use that form, otherwise known as the point-slope form. And then we'll eventually get it in the slope-intercept form. All right, well, we have the m part. We don't have the y1 part, so I'm going to leave that empty. So we've got negative 36 x minus, we do have the x part. They tell us that x equals 1, so I'm going to go ahead and use that. Now, how do I find that? The y coordinate. Well, I have an x coordinate, so if I want to find the y coordinate, all I have to do is plug it in. So I will need to find f of 1 in order to find the y coordinate. 1 to the 4th power minus 20 times 1 squared plus 64 is equal to 1 minus 20 plus 64, which is equal to 45. Okay. All right, so now I have the point 1 comma 45. So now I can plug that in for y minus 45 is equal to negative 36 times x minus 1. And in order to get it into slope-intercept form, I'm going to, let's see, distribute the negative 36. Negative 36 times x is negative 36x. Negative 36 times negative 1 is positive 36. Okay, and then I want to move the 45. So I'm going to do the opposite operation. I'm subtracting 45, so to do the opposite is to add. So y is equal to negative 36x plus 36 plus 45 is 81. And that's exactly what we have there. So whenever you're asked to find the slope of a tangent line, you need to find the derivative. That will give you the slope at any value x. Then if you want it at a particular value, plug that in. That'll give you the slope of the tangent line. And then to find an equation, you need a slope and a point. And you have to be at least given the x value so you can find the y value of that point. So whatever this graph looks like, x to the 4th minus 20x squared plus 64, at x equals 1, we have a negative slope. And that line, that tangent line, passes through 81.